Hey everybody, how you doing? My name is Dylan Saccone, and I will be teaching you how to write electron configurations and orbital diagrams today. So, right here, as you see, this is one of the main things you really need to know when doing that, when doing electron configurations and drawing the orbitals. And you know how many electrons each subshell and orbital can hold. So, when the S subshell has one orientation, P has three orientations, D has five orientations, F has seven orientations. And then each orbital will have 2 electrons in S, 6 electrons in P, D will have 10 electrons, F will have 14 electrons. It's something they can hold. And you can see in the examples when we're about to get started. So here, this is a big thing you really need to learn. It helps you out a ton. Helped me a lot to understand the order in which they go in. First, you'll start with 1s, then 2s, then it goes to 2p, then 3s, 3p, then 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, and then 5f, 6d, 7p, and you rarely use those. Those are for like ones with humongous electrons, but yeah, you'll barely use those. So in our practice problems, first we have carbon here. When you look at the periodic table, carbon has 6 electrons. So 1s can hold 2 electrons, like I showed you right here. S can hold 2 electrons. Then 2s can also only hold 2. And then 2p holds 6. As we go back here, showed you it can hold 6 electrons. But because there's only 6 electrons, we only need it to hold 2. Then when you draw the diagram, the orbital diagram, you want to make sure you fill this in right here. 1 up, 1 down, 1 up, 1 down. So then when you come here, you don't do the 1 up, 1 down. You need to fill them all in. It's like if you sit on like a bus or something. If there's a seat open, you're going to take the open seat. No need to sit next to somebody. You keep this one here. And you would go over, if you look at my cursor, this is just going to stay like that. And then for silicon, it has 14 electrons. So when you separate the 14, 1s can hold 2, 2s can also hold 2, 2p can now hold all 6 because it's needed, 3s can hold 2, 3p can also hold 6, but you only need 2 in this one. Fill in the arrows on your own. This is for the orbital diagram. 1 up, 1 down, 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 1 up, 1 down. And then since there's only 2 left over, no need for the up and down one in the first and second box. Spread them out, give them some space, and then you have 2 left over there. Pretty simple concept. It's actually very easy. Very, very easy, actually. And then for calcium, calcium has 20 electrons. See here how I didn't put 2? When you're usually doing electron configurations with the orbital diagram, you won't have to put how many, you won't have to put the 2 or the 6. You can just leave it how it is if you have the orbital diagram. But if you're just writing the electron configurations, make sure to signify how many are there, how many electrons each one holds. So back to this one. Calcium has 20 electrons. So 1s can hold 2, 2s can also hold 2. 2p, you'll need it to hold all 6. All 6. Now you have 10 electrons. And you have to move on. You move on to 3s. 3s can hold 2. Now we're at 12. 3p, you'll need all 6. All 6 will be filled in here. That makes it 18. Now we have 18 electrons. And now move on to 4s. 4s fills in the last 2. 20 electrons. Boom, bang, done with this one. I just want to point out, here, let me go back. See, a lot of the a lot of elements you'll see, you'll barely ever come into contact with the 5s. I meant with the 5F, 6D, 7P. But you also need to always make sure you understand how many F holds. Because if you do get there, when you do, you'll have to do it probably at least a few times. Make sure you know D can hold 10 electrons. So when you see we have 3 boxes for 6, you'll need 5 boxes when you're doing the diagram here instead of 3, as it's shown here with the P. You're going to need 5 for D. And then when you go to 14, you're going to need 7 boxes when you're doing the orbital diagram instead of just 3 or 2 or 1, as it seems. So that's it. That is how you write electron configurations and orbital diagrams. Thank you very much.